Okay, as promised, part 2 of your topic 5, part 1 study guide. We're just doing numbers 21 through 25 here because numbers 1 through 20 are worked out in the first video. So let's look at number 21. What I noticed right off the bat is that I have variables on both sides. So what I'm going to do is I'm going to start by drawing a line through my equal sign because that just helps me see that I have two sides. And I know that on the left-hand side over here, I've got parentheses. So I need to get rid of those parentheses, and I'm going to use the distributive property. So I'm going to multiply negative 3 times 2a. So negative 3 times 2a is going to be negative 6a. And then I'm going to multiply negative 3 times negative 3, which is going to be positive 9. So I've got negative 6a plus 9 equals. Now on the other side, I don't see any like terms, and I don't have parentheses. So I'm just going to copy it down as is. Negative 36 minus 7a. Okay, so let's just double check the left-hand side. Do I have any like terms? No, there's no more parentheses. There's no like terms. So this side is as simple as it can be, as is this side over here. So now let's identify our terms with a variable. Well, negative 6a and negative 7a. Which one of those is smaller? If you said negative 7a is smaller, you're right. And because that's the smaller term, that's the one that I am going to choose to move, although it doesn't matter which one you move. Now, in order to move this term, I have to use its opposite. So what is the opposite of negative 7a? Well, if you told me positive 7a, you're correct. So I'm adding 7a on both sides. Now, let's talk about the left-hand side. Negative 6a plus 7a. Well, that's just going to give me 1a or just a. And I'm going to bring down that plus 9. Now, on the other side, I'm going to bring down my negative 36, and my 7a's canceled out. Now, this is an equation that you know how to solve. I need to get that a by itself, so I'm going to subtract 9 on both sides. On the side with the a, my 9's cancel out. A is by itself. Negative 36 minus 9 is going to be negative 45. So a equals negative 45. Okay, moving on to number 22. Again, right off the bat, I see variables on both sides of my equal sign. So let's draw a line through the equal sign to remind us that we have two sides. And let's look at the left-hand side first. So I see parentheses. That means I need to use the distributive property. And I also have this minus m hanging out. I'm probably also going to have to combine like terms. But let's start with the distributive property. So we're going to multiply 4 times negative m. That's just going to be negative 4m. Now we're going to multiply 4 times 5. And 4 times 5 is 20. So plus 20, and I'm going to bring down our minus m. And all of that equals what we have on the other side. Now, over here on the right-hand side, no parentheses, so we don't need to use the distributive property. And also no like terms. There's nothing I can combine, so I'm just going to copy it down. So we have negative 18 minus 6m. Okay, now let's look back at the left-hand side. Do I have like terms? Well, yes, I do. Negative 4m minus 1m, those are like terms. So negative 4 minus 1 is negative 5. So negative 5m is what we have, and we're going to keep that plus 20. And that equals what we have on the other side, which is negative 18 minus 6m. Okay, so now on the left-hand side, there's no more parentheses, no like terms. It's as simple as it can be. Same thing on the right-hand side. No parentheses, no like terms. It's as simple as it can be. So let's identify our variable terms. We have negative 5m over here, and on the right, negative 6m. Which one of those is smaller? Well, if you said negative 6, you're right. So I want to move this term to the other side. I do that by doing the opposite. Since that's subtracting 6m, I'm going to add 6m to both sides. So let's talk about the left-hand side. Negative 5m plus 6m is 1m or just m. Now I'm going to bring down that plus 20. And that equals, on the other side, we have negative 18, but my 6m's canceled out. Now this is an equation that you know how to solve. I'm going to subtract 20 on both sides. So my 20's cancel out, and m equals negative 38. Okay, moving on to number 23. Selah paid $225.99 for a game system and then bought 3 equally priced games. She spent a total of $381.96. How much was each game? Okay, that's what we're trying to figure out. I'm going to let X be my variable, and X represents the price of one game, right? That's what we're trying to figure out. Okay, what is some important information that I might circle? Well, she paid this much for the game system. She bought 3 equally priced, oops, I don't know what just happened there, 3 equally priced games and spent a total of $381, oops, I don't know what's happening, spent a total of $381.96. Now it tells us which one's the total. We know it's $381.96. So I know I need to have equals 381.96, right? That means on this other side over here, I need a 3, I need a 225.99, and I need my variable X. So of the two numbers that we have not used, 225.99 and 3, which one should my X be attached to? Well, because X represents the price of one game and she bought 3 games, 3 needs to be attached to my X, so 3X, right? Now we also have the 225.99, so 225.99. So what operation connects 3X and 225.99? If you said addition, you're correct, because it's all how much she spent, right? Now this should be an equation that you know how to solve. So I'm just going to rewrite it over here. 3x plus 225.99 equals 381.96. Okay. Now we're going to solve this like a normal 2-step equation. We're trying to get that x by itself. So the first thing that we're going to undo is adding 225.99. So we undo adding that by subtracting it. So we are subtracting 225.99 on both sides. Now on the side with the x, 225.99 cancels out and I'm left with 3x equals, on the other side, when I put this in my calculator, 381.96 minus 225.99, I get 155.97. Okay, now to get that x by itself, we want to divide by 3 on both sides. So my 3's cancel out, x is by itself, and when I put this in my calculator, 155.97 divided by 3, I get 51.99. So that's my answer, 51.99. Well, 51.99 what? $51.99. Okay, number 24. 3 friends attend a matinee movie and spend $9 per ticket. They also purchase a small bag of popcorn each. The friends spend a total of $50.25. How much is a small bag of popcorn? Okay, so how much is a small bag of popcorn? We're trying to answer that question right there. So we're going to let X be our variable, and X represents the price of popcorn. Okay, what is some important information that I might circle? Well, there are 3 friends that go to the movie. They spend $9 per ticket, and they also buy a bag of popcorn each. They spend a total of $50.25. Okay, so we know where the $50.25 goes in our equation. It goes after our equal sign. So I'm going to go ahead and write equals 50.25, okay? Now we just have to figure out what goes over here. Now, let's think about this. I see $9 per ticket, and normally I say, oh, that goes with my variable. but my variable represents popcorn, right? Okay, so I know that 9 does not go with my x. Not exactly, okay? But I also see this word each. And remember, per and each, those are like important words. Usually they tell me that my variable is multiplied with that number next to that, right? But could I multiply 9 and x with something? Yeah, I could. So let's think about this. We know that each friend spends $9 on a ticket, and they also spend X dollars on popcorn. So I want to add those two pieces together. Now, that just represents one person. How many people went to the movie? Well, 3. So I put 3 outside of my parentheses. So 3 times 9 plus X equals 50.25. That right there is our equation. Now, we're going to solve that equation. So I'm going to rewrite it over here. And I'm going to draw a line through my equal sign. Now, to solve this, I'm going to use the distributive property because I see parentheses, right? So, distributive property. We're first going to multiply 3 times 9. So, 3 times 9 is 27. Now I'm going to multiply 3 times x. 3 times x is 3x. And all of that equals 50.25. Now to get that x by itself, the first thing I need to undo is this 27. Now is that a positive 27 or is that a negative 27? Well, it's a positive 27. So I undo that by subtracting 27 on both sides. Okay, so on this side with the x, my 27 cancels out and I'm left with 3x. And that equals 50.25 minus 27. So I get 23.25. Now to get that x by itself, I'm going to divide by 3 on both sides. So my 3's cancel out, x is by itself. 23.25 divided by 3 is 7.75. Well, 7.75 what? Remember, this is the price of popcorn. So $7.75 is our answer. Now, number 25, identify the pairs of operations that have inverse relationships. Remember that word inverse right there, it means opposite. So what are some operations that have opposite relationships? Well, let's start with addition. So addition, what's the opposite of addition, or what's the opposite of adding? If you said subtracting, you're right. So addition and subtraction have an inverse relationship. They undo each other. Okay, there's another pair of operations that have an inverse relationship. Multiplication, right? Well, multiplication, how do you undo multiplication? You undo it by dividing. So multiplication and division have an inverse relationship. So the two pairs of operations that have inverse relationships are addition and subtraction and multiplication and division.